Hi math class, I hope you're all doing well. Welcome back to another lesson. Great work yesterday making sure to show all of your work and all of your calculations. If you have any questions, please feel free to reach out and please visit me during my office hours. So for today's class, we're going to be looking at lesson 72, parts 1, 2, 3, and 4. So in our textbook, it tells us that some of these problems do not have remainders and that some of the problems have remainders. So we're going to see problems that have remainders and problems that don't have remainders. So we'll try solving one of each so that when we see problems similar to this, we know how to solve them. So let's look at question A. We have 706 and we're dividing it by 2, right? So we're doing a division question. So our first step for this question is going to be to figure out if 2 can divide into 7. It can't. Well, it can, but it will have a remainder. But that's okay if it has a remainder, right? So 2 can divide, how many times can it go into 7 without going over, right? 2, 4, 6, 3 times, right? So I'm going to put the 6 here and the 3. All this is doing is showing that 2 multiplied by 3 equals 6, right? So if I subtract this, this will give me a remainder of 1. So then I'm going to put this remainder of 1 and move it to the next number right over here. So now, instead of this being a 0, it's going to be a 10. So I'm going to try dividing the 2 into 10, right? So we know that 2 can go into 10 5 times, right? 2, 4, 6, 8, 10, 5. So I'm going to put my 5 right above. And now I'm going to try to divide the 2 into the 6, right? 2, 4, 6, 3 times. So I'm going to put a 3 at the top. So our answer is 353. So once again, we first started with the 2 and we tried to divide it into the 7, right? But that gave us a remainder of 1. So we knew that 2 can go into 7 3 times, right? 2 times 3 gives us 6. If we subtract that, that gave us the remainder of 1, which we then moved to the next place value. So the 0 turned into a 10. Then we had to divide the 2 into 10, which gave us 5. There was no remainder. And then we had to divide the 2 into the 6, which was 3, once again with no remainder. So now let's look at our next problem. For part B, for this problem, there also will be a remainder. Let me just write this question down. So we're dividing 460 by 4. So once again, for this problem, we'll have a remainder. I'll use a different color to show you our various steps once again. So once again, 460 divided by 4. So my first step is going to be to look at the first number, 4, right? We know that 4 can divide into 4 one time, so I'll put a 1 at the top. Next, I have the 6. I know that the 4 can go into 6 one time, but that will leave me a remainder of 2. So we can work on that. So I'll put a 4 right there, right? 4 can go into 6 one time, which will give me 4. So if I subtract this, this will give me a remainder of 2. Then I'm going to put this 2 with my next place value, which is going to be with the 0. So now this 0 is going to transform into a 20. So 4 divided by 20, or 20 divided by 4, gives me 5 without any remainder left. So my answer is 115. So once again, this is question B. So we wanted to divide 460 by 4. So we first started off by dividing into our first number that was underneath our division sign. 4 went into 4 one time. There was no remainder, so I moved on to the next number, which was 6, right? We know that 4 can go into 6 one time, and that'll leave us with a remainder of 2. So that's where that 1 came from, and that 2 is our remainder, which we then moved to our next place value. And then we divided the 4 into 20, because that 0 now had that 2 in front of it. And then we know that 20 divided by 4 gave us 5 with no remainder left. So our answer was 115. So what I want you guys to do now is to work on the next problems. For part C, and for part D. Remember, one of these problems will have a remainder and one of them will not have a remainder. So you can pause the video now, work on these problems, and then we'll look at part 2. So welcome back to part 2. So for part 2, I'll read what it says in our book. It tells us that these are multiplication problems that end with large numbers. You work these problems the same way you work them in a table. First, you write the division problem, figure out the answer, and write that number in the multiplication problem. So all that's telling us is that in order to solve for the multiplication problem, we have to change that problem into a division problem, solve that problem, and then we can find the missing number for the multiplication problem. So for part A of part 2, we have 7 multiplied by a number will give us 420. The way it is written, I don't even know how to solve, right? We don't know how to solve. So what we have to do is change it into a division problem. So I'm going to put this like that. Remember, the number that comes after the equal sign will go inside of my division problem. So the 420. And then the 7 will go in front of my division problem. So now all I have to do is figure out, can the 7 go into the 4? No, it cannot. So then I'll look at the next number as well. Can the 7 go into 42? Yes, it can. If we skip count by 7s or we use our multiplication chart, we know that 42 divided by 7 gives us 6. So the 6 will go right at the top. Now I have to divide 0 by 7, which will give me 0. So our answer is 7 multiplied by 60, which is the number we found out, equals 420. So what I want you guys to do is to use the same steps to find out the missing numbers for parts B and C. Once again, you're given the multiplication problem with a missing number. What you first have to do is change that multiplication problem into a division problem, solve, and then you'll find the missing number. So you can pause the video now, and then I'll see you guys in part 3. So welcome back to part 3. So it tells us in part 3, for each row, write a division problem and the fraction equation. So if we look at the chart, let me just quickly write this out. Sorry. We have our division sign, and then the next one is asking us to write as a fraction. Then we have we'll do the first 2 together, and then I want you guys to work on the other 2 on your own. And then we can draw. For this one, we have the fraction. So let's look at part A. In part A, we have the division problem, 35 divided by 7. So what we have to do is find out our answer. And then we have to rewrite this question as a fraction with our answer. Right? So we can first solve. We know that 7 can go into 35 if we skip count by 7s. Right? We know it goes 5 times. So our answer is 5. So I'm going to write that right at the top. So now I have to change this into a fraction with an answer. So once again, my fraction is 35 divided by 7. So I'll write that right over here. 35 divided by 7. And then I need to write the full equation equals 5. So that's my answer. For part B, I have my fraction. I can't solve the way it's written, so what I want to do is rewrite it as a division problem. Remember, the top number, or the 820, will go inside of my division, and then the 4 will go on the outside. So now, once again, just like we've been practicing, I'm going to divide the 4 into the numbers inside of the division problem. Right? 4 goes into 8 2 times. 4 can't go into 2, So I'll look at the next number as well. 4 can go into 20 how many times? 5. But we can't just write the 5. Remember, since the number that we're dividing into has 2 digits, we have to make sure that our top number also has 2 digits. So our answer will be 205. So then we can just write our answer right over here. 820 divided by 4 equals 205. So for parts for parts C and D, once again, you are either given the question as a division problem or as a fraction, and you have to find out the missing number and solve. So you can pause the video now. Once again, these are parts A and B, and you can work on parts C and D on your own. And then I'll see you guys in part 4. So part 4 will be our last part for today's video, and we're going to be looking at number families. Once again, these are like the number families we worked on in lesson 71. They have a fraction and a whole number. So let's look at part A, number family. So we will work through part A together, and then I want you guys to work on parts B and C on your own. So if you look at the number family in part A, we can see that we have the whole number 5, and then as our big number, we have the fraction 20 over 3. So what we have to do first is remember that we can't add or subtract a whole number and a fraction. We have to change this 5 into a fraction. So every whole number is over the number 1. So I'm going to put this over 1. In order to add or subtract fractions, they need to be over the same bottom number, right? This is over 1, this is over 3, so our bottom numbers aren't the same. So what I'm going to do as my first step is to get the same bottom number. So I'm going to multiply this 1 by 3. My next step is to remember that whatever I do to my bottom number, I have to do to my top number. So this 5, I'm also going to multiply it by 3. So now all I'm going to do right beside here is just rewrite this as a fraction, right? So 5 times 3 is going to be 15, and then 1 times 3 is going to be 3. So all we did so far is change this 5, that whole number 5, into a fraction that had the same bottom number as my other fraction. So our new fraction is going to be 15 over 3. So I'm going to just erase this because, like I said before, this fraction and that whole number that we had are the same thing. All we did is rewrote it. So now both of our bottom numbers are the same. So that means that we can either add or subtract these fractions. This is my small number. I'm missing my other small number, and I have my big number. So in order to find out my small number, I have to subtract. So I'm going to subtract 20 and 15, right? So 20 minus 15 will give me 5. And then my bottom number and my fractions will not change, so they will be the same. So since this is over 3 and this is over 3, this will also be over 3. So my answer is 5 over 3, or 5/3. So once again, your first step will be to change your whole number into a fraction, then to put that fraction over the same bottom number, like we did. Then make sure that whatever you multiplied your bottom number by, you multiplied your top number by. And then you have to figure out, are you looking for your big or small number? And then you're either going to add or subtract. Remember, the bottom numbers will be the same in all of your answers. So what I want you guys to do now is to try working on parts B and C using the same steps we did for this problem. If you have any questions, please let me know. Keep up the awesome work, and I'll see you in our next lesson. See you guys!